All right, so in this video, I'm going to talk to you about the most important concept of this entire course, and we're going to be talking about this concept every week until the end of the course. So you want to make sure that you have your 1.4 handout, chapter 1.4 handout, and that you take notes of anything I say here that you think might be useful to you later on. Take them right on that handout, okay? So think about that cliche, a broken clock is right twice a day, or a broken clock tells you the right time twice a day. It is true, right? But a broken clock isn't reliable because you don't know if at any given moment when you glance at it that it'll actually be telling you the right time. So you don't rely on that clock, and you don't point to that clock as a reason for believing it's a correct time, even when it happens to be showing you the correct time, right? Because you can't trust a broken clock. And deductive arguments have a quality that's similar to that. It's a quality called validity, and that's what I want to talk to you about here in this video. Validity is a quality that is possessed by deductive arguments only. And we're not going to talk about inductive arguments anymore in this class. We're only talking about deductive arguments, those arguments that deal in certainty for the rest of this semester. Validity refers to the form of a deductive argument, not its content. And what I mean by that is this, is that validity doesn't have anything to do with the topic or the words that are being used or anything along those lines. It has to do with the way the ideas are being brought into relationship with one another in an argument. It has to do with literally the structure of the thinking and whether or not the thinking is structured in a way that makes it reliable thinking. Whoops, I just previewed my next bullet point. All right. So here's the key concept, or the key principle of validity for us. In a valid deductive argument, the conclusion necessarily follows from the premises. Okay, now here's what that means. That might be confusing, but this is what it really means. In a valid deductive argument, it's impossible for the conclusion to be false when the premises are all true. Okay, so think about this. In a valid argument, if you have true premises, there is no way that conclusion can be false. The conclusion has to be true if the premises are true. Now, that doesn't mean that a deductive argument can't have a false conclusion. It can. But if it's valid, it'll mean that one or more of the premises is also false. Because in a valid argument, if the premises are true, it's impossible for the conclusion to be false. But if it's an invalid argument, it is possible. So validity is kind of like an on-off switch, right? So the light's either on or off. It's not sort of on or sort of off. It's either on or it's off. And a deductive argument is either valid or it's invalid. It's not sort of valid. It's not 80% valid. It's either 100% valid or 0% valid. And it has to do with possibility. Is it possible for the conclusion to be false even when all the premises are true? So here's a couple of arguments that I want you to consider. And what I want to know from you is, are these arguments valid? Okay, and so what I'm asking is, just go ahead and assume the premises, the first two statements of each one of these arguments. Just assume those are true statements. And ask yourself this, is there any way the conclusion could be false even when the premises are true? And if you can think of one way that conclusion could be false even when the premises are true, you will have proven the argument invalid. It takes one possibility. So why don't you go ahead and pause the video, see if you can figure out which one of these is valid and which one of these is invalid, or whether they're both invalid, and so on and so forth. And then when you're ready, go ahead and restart the video and we'll check your answers. Okie dokie, so let's look at the first one. All humans are mortal. Jack is immortal, therefore Jack is a human. This argument is invalid. Assume it's true that all humans are mortal. It is true. So it's true all humans are mortal. Let's just assume it's true that Jack is immortal. That doesn't necessarily mean that Jack has to be a human, because maybe Jack's a dog. And if Jack's a dog, it is true that Jack is mortal. And it is still true that all humans are mortal. But it wouldn't necessarily be true that Jack is a human. Maybe there's another person named Jack who is a human. Who knows? But it doesn't necessarily have to be the case. Okay, maybe there is a human named Jack, and if that's the case, then in this sentence, it would also be true, and then this would be true. But it's not true because of these reasons. It would be true only by coincidence. Now look at this argument right here. All humans are fish. Jack is a human. Therefore, Jack is a fish. This is a valid argument. Okay, this first premise isn't true, but let's just assume it is. Because if it's true that all humans are fish and Jack is in fact a human, there's no way Jack is not a fish. Jack has to be a fish if it's true that all humans are fish and Jack is a human. Because if Jack's a human, he's in this category of things that are fish. Every single human is a fish, according to the first premise, and Jack is one of those things. So if they're all fish and Jack is one of them, Jack would also have to be a fish. Okay, so this argument is valid. This one's invalid. Let's look at another one, a couple of them. All right, so take a look at these two arguments, figure out if one, both, or neither of them is valid. So pause the video, really do pause it. You want to test yourself on this. Pause it, and then when you're ready to check your work, restart the video. All right, so the first argument says that some CR students are female, some females are math majors, therefore some CR students are math majors. Is it true that some CR students are math majors? Has to be a true statement if the first two are also true. And the answer is no. This is an invalid argument. Here's why. Let's just say it's true that some number of CR students are females. And let's just say that some number of females are math majors. That doesn't necessarily mean that we can know with 100% certainty that some CR students are math majors. Because maybe the thing that makes sentence number 2 true is that there's some females at other schools, at other colleges, who are the math majors. This doesn't give us any indication up here that the females we're talking about happen to be CR students. Okay, so the first premise, I know that sentence is true. So first statement is true. The second statement is true because I know there's female math majors somewhere, but I don't know with 100% certainty that any of them are at CR. Okay, so this is a tricky argument because in this case, all 3 sentences happen to be true. It is true that some CR students are female, and it is true that some females are math majors, and it is true that some CR students are math majors. But it's not true because of these reasons. These don't make it true, just like the broken clock doesn't necessarily tell you the right time of day just because it happens to be showing it at that moment. Okay, so this is an invalid argument. This argument's a tough one. Okay, some logic problems are easy problems. No easy problems are problems worth doing. Therefore, some logic problems are problems that aren't worth doing. All right. Let's just assume it's true that some logic problems are easy problems. And let's assume it's true that no easy problems are problems worth doing. Would that mean it would have to be true that some logic problems are problems that aren't worth doing? And the answer is yeah. This is a valid argument. Okay, so here's how this works. Take a look at this first premise. It says there's some number of logic problems that are easy problems to do. This sentence says there's no such thing as an easy problem that's a problem worth doing. So when I look in my container of easy problems, and in this container is every single easy problem that exists of every single type, every easy English problem, every single logic problem that's easy, all of these, they're all in here. Every single easy problem is in this bucket. And I look at the problems in that bucket and I go, I see that none of these problems that are in the easy problem bucket are problems worth doing. No easy problems are problems worth doing. None of them. And then I look and I think, oh, well, because this is where all the easy problems are, and because none of them are problems worth doing, if some of those easy problems are also logic problems, then that would mean that some of those logic problems are problems that aren't worth doing. Because no easy problems are problems worth doing, and some logic problems happen to be easy problems. So some logic problems are problems that are not worth doing. Does that make your head hurt? Super important concept. We're going to keep on it. You're going to read about it. You're going to practice it. You're going to get totally good at this. This I know is a brain stretcher, but you're going to do a good job with it.